Hello everyone, welcome back. Today we're going to be discussing one of the statics problems that can be found in the textbook. And in this case, it actually involves two force members and learning how to draw free body diagrams that involve the two force members. So in this case, identify any two force members and then draw a free body diagram of each member of the frame. Out of all the examples on that page, I wanted to do the distributed load problem just to give you an idea of how you can try to approach one of these problems on an exam or on a homework assignment. And so one of the first things I ended up doing for this problem is I wanted to draw the picture that actually shows me in the textbook exactly, just so I have all of the components that I need in the beginning to know where I need to split it up, which in this case I would want to split it up right here to where you have a member AB and then you have a member of BC. The cool thing about member AB is that is the only member here that actually involves the distributed load. And as you can see here, the distributed load is a triangle, which we know how to solve for FR1 with that using 1/2 the base, which is your 6 meters, times your height, which ends up being your 200 newtons per meter. When you plug it into a calculator, you should end up getting 600 newtons as your answer for FR1. Once you end up finding that value, you can then plug it into your member AB free body diagram, which is shown here. That's why it's in the middle, because it's right in this position here. AX and AY in the moment of A is located here due to the fact that point A is a fixed end, and that's what you have to draw when you're dealing with a fixed end. And then you will have your pin at B, which gives you the BX and BY arrows here. Now, when you move on to the member BC, you will notice that BX and BY is also the pin, but it's drawn in a opposite direction of what is shown up here, because that is one of the rules that is discussed in class. You have to make sure you change the direction of the reaction forces on the two force members. They can't be the same on each of these members, or else you'll see an error occur somewhere. And once you end up changing the direction of those arrows, you will then basically plug in the rest of your values, which up here is your 800 newtons. And then you have your C, since your C is your roller value here. That is basically what the question is asking us to do, is just to draw the free body diagrams. But if this was just a regular problem and it asked us to try to find the reaction force values and what the members are, you can use member BC here to try to find your C, your BX, and BY, because there's only three unknowns in here. If you try to solve for values in member AB, you have 1, 2, 3, 4, and 5 unknowns. That is way too many to try to be able to solve for anything. If you go down here, you can try to take a moment at B to find your value of C, and once you find C, you can do sum of forces to try to find the rest of them. And then when you find your BX, BY, you then cut out 2 unknowns here, and then you have 3 that you can try to solve for now. And so it slowly starts to build on itself on how to try to solve the problem. And so it really just depends on where you need to start, but it all comes down to drawing all of the free body diagrams to make sure, hey, this is where I need to start. And so that is pretty much it for the problem. If you have any questions, just leave a comment on it. But other than that, I hope that this video was helpful in trying to explain a distributed load problem and how to draw free body diagrams that involve distributed loading. So thank you so much for watching.